Okay, now that you've watched the Khan Academy video, let's look at a little bit more detail about the radian measures and trigonometry. So for example, in quarter one, if you have an angle that has its initial side always on the initial side on the positive part of the x-axis, and if the terminal side is here somewhere in the first quadrant, right, if that's your angle theta, then that angle theta must measure somewhere between 0 and pi over 2. If you have an angle that measures, that has its terminal side in the second quadrant somewhere like this, I'll call this angle theta. Now angle theta here would have to be between what and what? Well, an angle that has its terminal side in the second quadrant is going to have its measure somewhere between pi over 2 and pi. Right? If you have an angle that has its terminal side in quadrant 3, so in other words, the angle looks like this, let's say that's angle theta, then angle theta there has to be between pi and 3 pi over 2. And if you have an angle that has its initial side on the positive x-axis, but its terminal side in the fourth quadrant, so something like this, if that's our angle theta, then theta must measure somewhere between 3 pi over 2 radians and 2 pi radians. So let's get back to the topic of coterminal angles. Coterminal angles, as we said, have the same initial side and the same terminal side. So to find a coterminal angle, you will want to add or subtract multiples of 2 pi. So let's find an angle that is coterminal with 9 pi over 4 that's between 0 and 2 pi. So in order to do this, we're going to take our 9 pi over 4 angle that we are given, and we are going to add or subtract a multiple of 2 pi. We want to end up with an angle between 0 and 2 pi. 9 pi over 4 is too big because that's already over 2 pi. But if we subtract 2 pi from this, we will have 9 pi over 4 minus, if we get a common denominator here, we get 2 pi can be written as 8 pi over 4. So we get 9 pi over 4 minus 8 pi over 4 is pi over 4. So that means that 9 pi over 4 and pi over 4 are coterminal. So is pi over 4 the only angle that's coterminal with 9 pi over 4? No. You could just you could add 2 pi instead. So 9 pi over 4 plus 2 pi would be 9 pi over 4 plus 8 pi over 4, which is 17 pi over 4. So that would be another coterminal angle. But pi over 4 here is our only coterminal angle that is between 0 and 2 pi. All right, let's try this example. Find a negative angle that is coterminal with 5 pi over 6. So 5 pi over 6, we would want to take 5 pi over 6 and subtract 2 pi. So we'll get 5 pi over 6. Again, we need a common denominator, so we want to get something over 6. That's going to be 12 pi over 6, and that's going to give us a negative 7 pi over 6. And let's look at visually what's happening here. So we would have 5 pi over 6. Here's the initial side. I know that pi is 6 pi over 6, and that would be exactly this far on the circle, but we don't want to be that far around the circle. So we would want to say 5 pi over 6 is about here. So this angle right here is 5 pi over 6. And if we go the other direction around the unit circle, this way, that would be negative 7 pi over 6. So they are coterminal angles. All right, two angles are complementary angles if their sum is pi over 2. Well, you know from geometry that if two angles are complementary, they add up to 90 degrees, right? So they either add up to 90 degrees or they add up to pi over 2 radians, because 90 degrees is equal to pi over 2 radians. All right, so two angles are supplementary if they add up to 180 degrees or pi radians. So let's take a look at an example of finding complements and supplements. Can we find the complement and the supplement of pi over 6? So if we want to find the complement and the supplement here for pi over 6, remember that pi over 6 plus the complement, I'll call the complement c, has to add up to pi over 2 radians. So if I solve for c, I'm going to subtract pi over 6 from both sides to get c by itself. and I end up with pi over 2 minus pi over 6. I need to get a common denominator. Didn't leave myself much room here. And so we get 3 pi over 6 minus pi over 6. So the complement here would be 2 pi over 6, which is the same as pi over 3. So that would be the complement to pi over 6. If we want to find the supplement for pi over 6, then let's call that s. So pi over 6 plus the supplement, well, remember they have to add up to pi radians. So if we set up pi over 6 plus s, that has to equal pi. So if we subtract pi over 6 from both sides, we end up getting s equals pi minus pi over 6. Getting a common denominator, that would be 6 pi over 6 minus pi over 6, and that would leave us with 5 pi over 6. That would be the supplement. So pi over 3 is the complement, I'll abbreviate, and 5 pi over 6 is the supplement. All right, let's try one more of these. What about if we are asked to find the complement and the supplement of 5 pi over 6? Well, find the complement of 5 pi over 6. Well, we have 5 pi over 6 plus some complement, some c, has to add up to pi over 2. And when we try and solve this, we subtract 5 pi over 6 from both sides, and we end up with a complement equaling pi over 2 minus 5 pi over 6. And that would give us 3 pi over 6 minus 5 pi over 6, which is a negative 2 pi over 6. Well, that's a problem because we have to have positive angle measures. So if I refine my definition here, two angles are complementary if their sum is pi over 2, and they must both be positive. So if you end up with, oh, my complement's going to be negative, well, that's not really a complement at all. Okay, so that's it for this lesson, and you have some questions to answer at this time, and we'll see you next time.